Have you ever wondered why lemons are so sour? What about why soap makes your hands feel slippery? The answer lies in chemistry, specifically in the fascinating world of acids and bases. They're everywhere, from the food we eat to the cleaning products we use. In this journey into the microscopic, we'll uncover the secrets of these chemical superstars. We'll learn what makes an acid, and a base a base. Get ready to explore the exciting properties of acids and bases and how they impact our daily lives. Acids, those chemical compounds with a sour taste, pack a punch. They are found in many everyday items and play crucial roles in various chemical reactions. Think about biting into a lemon. The intense sourness you feel is a direct result of the citric acid present in the fruit. That sourness you experience? That's the citric acid at work, giving lemons their distinctive tangy flavor. Acids are like tiny superheroes with the power to donate protons, those positively charged particles that make up atoms. This ability to donate protons is what makes acids so reactive. But acids are more than just sourpusses. They are essential in many industrial processes and biological functions. They have some pretty amazing properties. For instance, they can change the color of pH indicators, helping scientists determine the acidity of a solution. Acids can react with metals, sometimes even dissolving them. This reaction is often used in metal etching and cleaning processes. That's why it's not a good idea to store acidic things in metal containers. The acid can corrode the metal, leading to leaks and contamination. Acids can also be electrolytes, meaning they can conduct electricity when dissolved in water. This property is crucial in batteries and various electrochemical processes. On the other side of the pH spectrum, we have bases. These substances are like the opposite of acids. They're slippery to the touch and often have a bitter taste. Think about the feeling of soap on your skin. That slippery sensation. You can thank a base for that. Bases are the proton acceptors of the chemical world, meaning they gladly take those positively charged particles that acids are so willing to give away. When dissolved in water, bases can release hydroxide ions, which are negatively charged. Section 4. Acids and bases in action, from stomachs to soap. Acids and bases aren't just confined to chemistry labs. They are integral to many processes and products we use daily. They're hard at work all around us, playing essential roles in our daily lives. From the food we eat to the products we use to clean our homes, acids and bases are everywhere. Take our stomachs, for example. The stomach lining produces hydrochloric acid, a strong acid that helps break down food into nutrients our bodies can absorb. This acid is crucial for digestion, breaking down complex food molecules into simpler forms. Without it, digestion would be much more difficult and less efficient. Bases are equally important in our daily lives. They neutralize acids and are found in many cleaning products. They're found in many cleaning products, like soap and detergents. These bases help to break down and remove grease and grime effectively. That's because bases are great at breaking down grease and grime, making our cleaning tasks easier and more efficient. Baking soda, another common base, is often used in baking to help cakes rise. It reacts with acidic ingredients to produce carbon dioxide gas, which makes the batter expand and become fluffy. Section 5. The pH scale, measuring the power of acids and bases. How do we measure the strength of acids and bases? This is a fundamental question in chemistry. That's where the pH scale comes in. It is an essential tool for scientists and researchers. It's like a ruler that measures how acidic or basic a substance is. Just as a ruler measures length, the pH scale measures acidity and basicity. The pH scale ranges from 0 to 14, providing a comprehensive spectrum. Substances with a pH less than 7 are acidic, such as lemon juice and vinegar, while those with a pH greater than 7 are basic, like soap and baking soda. A pH of 7 is neutral, like pure water. This means it is neither acidic nor basic. The lower the pH, the stronger the acid. Strong acids, like battery acid, have very low pH values. The higher the pH, the stronger the base. Strong bases, such as bleach, have very high pH values. Section 6. Keep exploring. The world of chemistry awaits. Acids and bases are just the tip of the iceberg when it comes to the fascinating world of chemistry. From the smallest atom to the largest molecule, chemistry is all around us. It explains the world we live in and how things work. So, keep asking questions, keep experimenting, and keep exploring the wonders of science. There's always something new to discover.